Okay, here is a basic primer on Hardy-Weinberg equilibrium compared to a disease state, a genetic disease state like cystic fibrosis. Let's start. So let's say you're given that 1 out of 2,500 humans has cystic fibrosis, and you know you're also given that they are homozygous recessive. So you know that P is the frequency of the dominant allele, and Q is the frequency of the recessive allele. And so therefore, P squared is big A, and 2PQ is the frequency of big A, small a, and Q squared is the frequency of small a. So you're given that. You know that. And you know that 1 out of 2,500 people have cystic fibrosis, and they're all small a. And small a is Q, so small a is Q squared, as we just said. So what do? You square root your total number of humans. I'm going to toggle back and forth. I've done the math. So 1 out of 2,500 equals 0.0004, and the square root of that is Q. And so therefore Q comes out to be 0.02. So you could be given different questions about this. Well, let's say you're given that you're asked how many alleles are recessive. So you know that Q is 0.02. You multiply that times 5,000 alleles, because every person has 2 alleles because they're dihybrid, or diploid, right? So 2% times 5,000 is the frequency of little a, which is 2% times 5,000 is 100 alleles. Oops, let me erase that. And P is therefore 4,900 alleles. But how did we get that? Well, that's the leftover alleles, but let's just do the math real fast. Now P is 0.98, and I know that because P plus Q equals 1. So 0.98 times 5,000 again. It must be 5,000 because every person has 2 alleles, and therefore 0.98 times 5,000 is 4,900. But let's now do the remaining things we have to figure out. You could be asked for how many people are big A, how many people are carriers, and how many people are small a. Well, you know that that's one person. That's 1 out of 2,500. That's what you know. You're given that. But how many people are big A? How many people are big A, small a? Well, we know that P is 0.98. So big A is 0.98 times 0.98, which is 0.9604. So P squared is 0.9604. And how did I get that? Because that's P times P, and P is 0.98. So 0.9604 times 2,500, not 5,000, 2,500 people. Now, how do I know when to multiply it by people or alleles? Well, look, the question's asking for P squared. P squared is a person, right? P is an allele. P squared is a person. Now, P squared is big A. 0.9604 times 2,500 people is 2,401 people. So, how do we figure out the carriers? Let's say I ask you or someone asks you for the carriers. Well, the carriers are always 2 times big A small a, which is the same as 2pq. It's the frequency of. And so 2 times p times q, that's 2 times 0.98. That should be 0.98, not 9.8, sorry. Let me just erase that. That's 0.98 times 0.02, which works out to be, I did the maths here somewhere, 0.0392. 0.0392. That's a point. And if you multiply that by, again, 2,500 people, not alleles, people, because that's a person. That's a person. Or a flower or something. It's an organism because it's a heterozygote. It's the frequency of heterozygotes. So that works out to be, if you do the math there, it's 98. So 98 people. So 2401 plus 98 plus 1 is 2,500. We've accounted for all the people. And up here we've accounted for all the alleles. The total alleles is 5,000. Okay, hope that helps, guys. I'll talk to you later.